good afternoon. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. So today we are having a forum and discussion about pioneering the Photonic Intelligence Era. So we have speakers from Khalifa University, from Abu Dhabi University, from JNU, and we also have expertise within our internal team. So the forum, the idea of today is basically to discuss the challenges, the opportunities facing the photonic intelligence and how we can actually, as QRDC, drive the ecosystem for chip development as well as being the first in the MENA region. So, and we will talk about our project as well, so the people, the milestones we have achieved in 1 year, and what's also our plan for this year. And one of the major projects at QuantLase is the QRDC, which is to do with the communication and security, and this will also be presented by our scientists. So first I would like to call Dr. Pramod, who is the Director of Research, to give an overview about QuantLase and the work and the overall mission and vision of our center. Thank you.
Hello.
Yeah.
Hello. Thank you very much, Lena, for giving nice introduction. And you already actually projected the idea behind to organizing this meeting. It's not really these except this version of the previous meeting which we have celebrated in December 9. So we are gathered all together. So the idea behind this gathering is to, because as last time I already discussed with them, I feel there is a gap between university and marketing. So the idea of this gathering is to distinguish scientists from the university, institute, and of course industry. So we sit all together and share their experience about how to deploy this technology from lab to public domain for a useful case. So this is the bridge actually. So QuantLase is the, I think, right place to start with this idea and to create the ecosystem in MENA region, particularly in Abu Dhabi. So because if you think about a product, you have to create your ecosystem. You have to think about the how to create this force, working force in a quantum scientist in the university. So university alone cannot help, industry alone also cannot help. So if you put university and institute, put all together and exchange their idea. So this is the things actually I wanted to raise today's meeting. So welcome you and thank you very much for being here and be a part of this organizing this meeting. So I welcome you and let's, without any further delay, let's start our meeting. So thank you very much.
Thank you, Dr. Pramod. So we'll start off basically, we always highlight our scientists and their work and what they, and obviously we can't go further without our scientists, but also they are our engineers, which we are very proud of. And we have a multidisciplinary team of biomedical engineers, electronics, and optics engineers as well, who basically are the basis of QuantLase research, and they transform our ideas to product. So I would like to call Engineer Renuka, who would give just a bit about the Department of Engineering.
A few words about the engineer, because engineers are the really workforce for making the optics working in the laboratory. Electrical engineer, electronics engineer, computer scientists, they all are working all together to make our system working in the laboratory level. So I really appreciate their input. So thank you very much for being here.
Thank you.
Hi everyone, good afternoon. I know you all are eagerly waiting for the talks and the panel discussion. I won't take much of your time, just a couple of minutes. I'm Renuka, I'm an electronics engineer. Today I stand before you representing the engineering team at QRDC. So I'll discuss who we are, what we do, and how our work impacts QRDC. So let's get started. So this is the brilliant team of engineers at QRDC. Ms. Danny, Mr. Libin, Mr. Tanaji, they all are from the optics background. Ms. Ruchi is an assistant scientist. Mr. Sufail is an electrical engineer, and I am a biomedical engineer. So you have met the team now. Let's go on to what we do. As you might have already noticed, we all come from different areas of engineering: electrical, electronics, biomedical, optical, right? So we work across different stages of product development. As for the optical engineers, they design benchtop optical systems, the testing, their alignment, assembly, calibration. So everything respect to optics are handled by our optical engineers. Now, when you come to the electronics part, we can design electronic circuits, develop and fabricate PCBs, working like almost working functional PCBs. Another thing is we have equipments like soldering stations, CNC machines, reflow oven, which are used for the fabrication and development of PCBs in-house. Another interesting work that we do here is the automation of optical systems. By automation, what I mean is, let me give you some examples. Like, if you want to, say, move or rotate the halfway plate from, say, 0 degree to 90 degree, or you want to open and close the optical shutter with respect to maybe the pulse width of a laser beam, you want to flip a mirror, you want to move a sample. So all these are done by automation. And by automation, what I mean is it is actually an integration of sensors or motor assemblies to these optical components. So we have done automation in almost all of the projects here, like the QKD and the imaging. Now, apart from the optics and electronics, we have 3D printers in this facility so that we can design, print 3D enclosures for the optical systems, and whether it be a mount for the optical components, so we can print it here in our facility. The main thing, the most important thing is the integration of all of these, the optics, the electronics, the 3D assemblies, everything put together, we give you, innovative products and solutions. So this is the kind of work that we do here. Now on to the next question is, how does our work impact the company? First and foremost is the innovation. So you give us ideas, we convert those ideas into workable solutions or products. Then comes the rapid prototyping. So as I said, we have rapid prototyping equipments in our facility here, whether it be fabrication of the PCB or the 3D printing. It makes the process of device development so much easier, faster. You have it in-house, you do the testing. If it doesn't work, you can reprint it, modify it. So everything is in our facility, so it actually makes the whole process faster. Next is the reliable test solutions. So we are certain that the products that are developed at QRDC, they are reliable, dependable, and they meet high standards. And last but not the least, the very important factor is the cross-team collaboration. So we work closely with all of the teams under QRDC, whether it be the group of scientists, the technicians, the operations, administration. So we work closely with them to solve problems efficiently and clearly. So yes, as I have mentioned here, our goal is simple. You give us the idea, and we'll give you the realistic product. Yes, so scientists discover what is possible, engineers make it usable. I would, thank you. I would actually like to add something. So the other day, Dr. Pramod was asking me if I wanted to, represent the engineering team here. And what he said was, optics is nothing without electronics. They go, hand in hand. So even I thought the same. What happens is when you talk about quantum or optics, lasers in a, high, high spatial this thing, what happens is sometimes engineering, it goes unnoticed. So thank you, Dr. Pramod and Ms. Leena, for giving me an opportunity to represent the engineering team here at QuantLase, and hope you enjoy the further talks and discussions. Thank you.
Thank you, Monica. Thank you so much. I just want to highlight today is a forum, so we're looking to discuss, and so if anyone has any questions for any of the sessions or engineering department, please do feel so. So our next talk is going to be represented by a head of product development. So in the last year, we have achieved so much. We are proud to say we are the first in the MENA region to develop a chip that is in-house, designed by our team. And we are creating the ecosystem for the UAE and market. So the next talk will talk about our project, which is the Photonic Intelligence Processing Unit, how we are transforming this to a product device soon into chip. And I would not go further, so I will let our head of product development, Dr. Salman, to come to the stage. Thank you.
Thank you very much, Ms. Leena. Appreciate the introduction. Thank you, Dr. Pramod. Thank you, Mr. Shaz, for facilitating QRDC as a platform, from which we've already positioned our work as, a key differentiator. Now, the theme of our work specifically, when we talk about our chip development program, is, as Dr. Pramod mentioned a number of times, and in a number of talks, formally or informally, that a chip technology, we are positioning it as an international launch pad. It's a platform from which we position our product development. And that's my connection, obviously, with QRDC. My background is in chip development over the last 15 years, and I'm very happy, very proud to be a part of QRDC representing the product development team. And with this note, today I'll talk about our chip development program in details. I know it's 20 minutes, I'll try to keep it short. There's a number of things we've already delivered, very high impact, and if I start talking about them in details, it could go over hours and hours, but I'll try to keep it sweet and short. So today I'll be talking briefly about our product delivery milestones that we've already achieved in 2025. And they are all related to, obviously, in the broader domain, our product development, and within that, obviously, our chip development program. So our mission and vision is what led me to join QRDC. Our mission is to advance the frontiers of photonic technology in medical imaging, secure communication, computing, high-performance computing, and obviously converting our research innovation into chip-ready, deployment-ready, and scalable solutions. Now, how we do this is we have a product development roadmap. We have our vision, and what we are doing is we're already leading the transformation of photonic science to and the research to a deployment-ready solutions. We're already, within our work, within our platform, we are positioning QRDC first, and by extension, of course, UAE, as the driving force behind pioneering the chip-level deployment-ready solutions. And it's very simple. At QRDC, we are actually using PIC technology as a launch pad, as a platform to achieve product development and productization. Having said that, I'd like to briefly brush through the regional impact that we've already created. We've already announced several milestones. One, industry-grade communication is to use product white papers. So in 2025, we started with our flagship product white paper, Photonic AI chip platform, and that's that's the key project we will be talking about today. Start of this year, in January, we've released our PIPU, Photonic Intelligence Processing Unit white paper. Now, this is the first of its kind work, not only in the MENA region, but globally in the optical computing community as well, because obviously there are a lot of strong research collaborations, groups around the world, but this type of work, the work we've reported in our second white paper, is really the first of its kind, and we are very proud of that. What's coming next is, in the very near future, we'll be releasing our detailed work on our chip manufacturing. The test and packaging and all will be included in the next white paper. So this already speaks volumes about the work, the impact that we have created, not only within UAE, but also on the global stage. When we talk about the product development, obviously there needs to be a clear strategy in place. When we talk about product development, obviously it's a bold, but also a very practical step where we talk about transitioning this research from lab to deployment to the field. Without a clear strategy in place, the risk is that this innovation becomes immobile. It won't move. And that's the risk. When it comes to product development, we can't afford that. We can't afford to have that, that risk. So it must move on from lab infrastructure to field. And to do that, obviously, we have a consolidated and a very thought-out strategy in place. There are 4 key pillars of our product development strategy. And obviously, with this, I'll talk about our chip development program. So with the first white paper, we've already positioned our strategy, how we anchored the design to UAE to QRDC. Now, that's a key differentiator, and that's exactly the business model where big companies like NVIDIA, Apple, they're exactly operating on this line. They do not own any fabs, they do not own any factories, but they own the product. Why? Because they own the design, and that's exactly what we've done. Now, when that's done, obviously, we leverage our partnerships to secure open source foundry partnerships across EU, not only across EU, but globally, and this is how we've manufactured our chips already. Now, a key bit which differentiates us strategically from, let's say, the rest of the players in the region is we have a clear export control strategy. Because once you make a product, you need to fly it into the country. Without that export control strategy, this will never happen, and that's the biggest risk. Having said all this, obviously, at this point, because we do not have any fabrication manufacturing facilities here, we have to use our strategic partnerships to get the job done. So that's a bit about our, how we move our innovation from lab to fab, and ultimately from fab to deployment. With this, I'd like to, again, briefly talk about our achievements on a number of points. Starting with design, we've already validated our photonic matrix multiplication chip design framework using an industry-grade toolset. Now, that's big, because that means when you have a design, it must survive a very rigorous and demanding industry protocol. If it can get through it, that means your design is manufacture ready. We've already done that, and that makes it first UAE design, which is cleared to industry grade, which means we're already talking about scalability, manufacturing, production. When it comes to production, obviously we got our matrix multiplication chips back in November 2025, and those are again the first industry validated silicon photonics chips. Currently, we are driving the assembly process, which means we are right now in the phase of having our modules delivered to us, and which means we are driving all the system level integration decisions to come up with an assembly solution. And there is a slide here which shows a 3D render of the assembly that we will have in a very near future. Now, in terms of infrastructure development, now that's, again, a key block which needs to be highlighted. Our Photonic Intelligence Processing Unit infrastructure is, again, a first of its kind in the MENA region. It's right there in our computing lab. we've established a first homegrown infrastructure for Photonic Intelligence Processing Unit, and that's the key subject of our second white paper. Everyone's encouraged to read. It's very nice. It positions our work in a very clear and an effective, both in terms of technical and a marketing communication manner. And that makes the link to the final bit, which is the communication. We've released 2 flagship product-grade white papers on photonic chip technology and our PIPU technology. Everyone's encouraged to read, please. A bit more about our product development strategy, and here I'd like to touch on the use case. So obviously, when we start developing products, it cannot be a wild ideation. It has to be what we use, a reverse mapped model. We imagine what would the final product look like, what would it do, and then we retrofit all the development in a reverse mapped model. So the timeline's fixed, the deadlines are fixed, and then we retrofit all the developments to realize that product, which means, let's talk about, so this is obviously not an outsourcing work. This is something which needs to be cleared. And what we are doing is we are following the exact model of the fabless companies worldwide, which means we own the design, and then we use our partnerships to get the product tracked through the various product development life cycles like design, manufacture, test, and package. So we start with a use case. In our case, it was photonic matrix multiplication. Why we refer to this is because matrix multiplication is the key operation underpinning all AI operations. So the idea is to transfer this into chip scale. So we started with a use case definition, and then we identify what are the building blocks on the chip which should be needed to do the job, as we talked about earlier today. Once that's done, then we look into what would be the suitable ecosystem partners. We identify partners. We have and this is what we call an ecosystem. Once that's done, then we select material platform. There are a number of trade-offs related to different material platforms, silicon photonics, indium phosphide, etc. We consider everything. Basically, in this case, it's a project requirement. We have to deliver it within a certain time, within a certain budget requirement, and that dictates what type of material platform we select. Once that's done, then we begin our work on export control compliance. We arrange for all the paperwork needed from different ministries across the EU governments to ensure that once we develop our product, it will be smoothly flowing into UAE. That's a key bit, that's a key requirement. And once that's done, then we align all the design, manufacture, test, and packaging segment, and we execute the product development. This is a key strategy that we've used, and we are happy to see it's yielded results. And this is what I wanted to, in connection, talk about our roadmap. So our roadmap, again, it's not based on just a wild scope and a wild idea, no. It's calibrated to yield deliverables. And as an instance, in July last year, we started with the design. Once it was validated, we released our white paper. After that, we got the chips manufactured. And right now, we are on track for delivery of our final modules, the hardware assembly. And we're very happy, we're very pleased to announce that even our initial roadmap was calibrated for May delivery of the module. We are much ahead in time, and we'll get the delivery in only 3 to 4 weeks. So that speaks volumes about the delivery, the execution strategy of our product development approach. And a proof of that is shown here. So this is just a hardware product form factor. Now, form factor is a key bit which all the product development companies need to definitely be aware of. When we design something, it's based, it's rooted in practical applications. So an example, we started with the chip design first. Once the design was ready, we converted that into a silicon photonics chip. Once that was ready, now we've already got our 3D render, a drawing of how the chip sits on the assembly, which is the third image from the top. And finally, this would be the module delivery. This would be how the 3D form factor for our product would look like. So that's a proof. These are all generated from industry-grade tool sets. This is exactly how our product would look like. Finally, I want to talk briefly about export control. So this is very important. One of the biggest risks with the chip product development is you spend millions on a product development only to find out at the end that you cannot move it out to the borders because it's not allowed. So that type of thing we have to do first. That's exactly what we call the reverse mapping. So we do the clearance first. Once that's done, then we start with developing the product. And in the process of developing our chip products, we've already gone through a number of technology metrics which would trigger an export control review from different governments. And we've identified those parameters as the bandwidth, performance, speed, temperature operation, sampling rates, and radiation hardening. We are obviously pleased to confirm that our technology development is not infringing into any thresholds that would trigger an export license for the first phase. And in doing so, we had to go through in details on the European Union export control regulations of 2021 and another agreement called Wassenaar Arrangement. That's key. It applies to export controls along the lines of chip technology development. So we've already done that work. Finally, this is how our product looks like. So we started with an idea, a vision that came from Dr. Pramod, and he said, I want to realize a matrix multiplication which would do this and this and this. This is how exactly it would look like. We've got inputs to the chip in form of external laser interface directly to the silicon photonics chip. We've got a mesh structure based on Mach-Zehnder interferometers. That does all the job of matrix multiplication. Once that's done, then we monitor the signals out of the chip using an external interface, which will confirm that a matrix multiplication operation is indeed happening on the chip. So this is exactly how our product would look like. So again, it's just a glimpse into how we are operating, how we are executing on our product development timeline. Nothing is random, nothing is wild, everything is planned and according to a strategy. And that, I believe, differentiates QRDC from a number of players here, that we have an informed and a calibrated product development roadmap, which is set to yield product deliverables, and you've already seen the proof. I think with that, I would conclude. That's everything. It's an opportunity for discussion as well. If there's any question from anyone, please feel free to.
Thank you very much, Dr. Salman, for your question.
Thank you, Dr. Salman, for a nice and concise introduction about the PIPU. In the beginning of the opening of the event, Dr. Pramod mentioned about the collaboration between industry and academia. In your presentation also, you have mentioned about building ecosystem. We have the honor of having two doctors from the academia. Where does the academia stand in your ecosystem? From here, what do you see? What are your expectations with regards to the academia ecosystem?
Thank you. I think when it comes to the role of academia, it's supposed to be like a brain which drives the innovation. Every industry, there is, for example, on the budget requirements of every industry, they have a significant allocation to R&D. Now, what that means on ground is when it comes to collaboration between industry and academia, academia plays a very significant role. But the way I see, one of the missing pillars of the strategy is that sometimes, because there's a very clear difference between research, innovation, and a product development. Both of them operate on an exactly opposite line. Research is making ideas, throwing out ideas and seeing what we can do. But product development is the exact opposite approach. It's not based on wild ideation. It's based on what we have to deliver and what we need to do to make it happen within the timeline. So there needs to be a strong bridge. And in response to Mr. Shiraz's question, I think academia has a very constructive role to play here, and that is, in my opinion, channeling innovation, providing ideas, filtering them out in a manner that's ready to drive the innovation within industry. Because once you're ready with that, then you put that thing into industry, and then they drive it forward using their product development methods. Now, these two approaches, although opposite, but there is an overlap, and that is understanding each other's approach. Currently, there is a lack of bridging between academia and industry. Most of people, people from industry, they don't go much into academia conferences, and same is true for the round as well. So I believe academia has a lot of role to play, and the future generation, for example, trained in the chip technology development, that would be the seed of the next generation of innovation. So we have to make sure to form this bridge, and obviously, within this region here, QRDC is one such bridge. We're very happy to be part of this program and this platform. I hope that gives some idea.
Anyone else have a question? Anyone? Okay, I have a question
Yes,
for
please.
you. Okay, so you came from UK about a year plus now. So, and you have been obviously in the UAE. So what do you see that differentiates QRDC? Like how are things here in the MENA region when compared to the strength that we have here when you compare it to Europe and UK?
Okay, I think that's a very nice question. Well, I've seen a key difference here, but now this is specific to QRDC only. What we are doing here, for example, we have activated our strategic partnerships with very leading companies. Yeah, for example, Lucida Photonics, VLC Photonics. These guys are considered the kings of chip technology industry in the EU as it stands currently. Now, the key difference between these two different realms is here, I think we are standing on a pyramid on the top of, the quality, and we look at which is the best delivering partner. We are not experimenting with anyone because we have a budget, we have a timeline. We're not in a position to waste money on trying different partners. No, we know which partner to go for. Why? Because we've done our work. We know what they can deliver. Now, that's very different from the European ecosystem itself. Lucida, for example, they have a budget for R&D, and they're free to experiment with their resources, with their bandwidth, with their money. We can't do that, which means it puts us in a position of strength. We're already standing at a point where we have a gate, and we say, no, only the best partner goes through it, and we partner with you. And they're very happy to pitch to us. From this project, the feedback that we got from Lucida is that this project is already testing them to their extreme. Because the form factor that I've shown you, it is not standard. This one is not standard. This is very bespoke. It's very custom. It's only custom for us. You will not find this type of thing anywhere in the industry because it's made specifically for us based on our system level decision. So that, I think, is the difference. What we are doing here, we're literally driving the innovation, the cream of innovation coming out from these companies. And I can tell you with confidence that they have not seen this type of initiative before from this region.
That's great. Thank you very much, Dr.
Thank you.
Salman. Can we have a round of applause? One more
Yes, of
question.
course.
Hi. Yeah. So just to continue, in continuation to your response to the question that the collaboration between academia and a research lab like this, like you said that when the academia does research, there is no, of course we are posing questions, but there is no product in mind. That's how mostly the academicians work. But with you, there is a product and there are deadlines, right? So just a question, how do you deal with the stress and the pressure that comes with deadlines and something that you have to kind of achieve by a certain date? And you were giving a map, and I was thinking, what you're closer to a date and you don't have something in your hand. How do you deal with that?
Yes. So obviously, professionally, we do deal with stress in a very positive way. In this program, I'm given deadlines by Dr. Pramod and Mr. Shiraz. This is what you have to achieve. I think the key to that is because with this, now this answer is specific to chip technology because that's my expertise. I don't know any other specific technology besides this. With this technology, with this industry, the supply chain is so much fragmented, which means the different strengths of the supply chain are, for example, design houses are in one part of EU, manufacturing fabs are somewhere else, test and packaging houses are somewhere else. Now, in addition to knowing the geostrategic importance of this, you also need to have an understanding of the strengths, the weaknesses, which partner to tap where. These type of things, in my opinion, from my experience, if you do this type of analysis in a balanced way, it already gives you an idea of which partner to go for. But the key is that you will have to retain the ownership of the technology because then it becomes, it's very dangerous. It becomes outsourcing. Outsourcing, there's no intellect in outsourcing, yeah? And if you go to a company, you tell them, we're going to pay you $1 million. Can you develop this product? They will never do it for you. Why? Because in that case, they don't want to position themselves as taking the responsibility for your product. No, you have to take the responsibility. And in my opinion, based on my experience, if you were to execute against a tight timeline, you have to be very careful with which partner to select, which technology to select, which platform to select. And most of these things would come from a direct hands-on experience, literature survey, book knowledge based on books normally doesn't help there. So that comes from experience. And if there is a bridge between an academia and industry, I think that bridge helps nurture this talent pool, I would say. That would be my response. But obviously, if there's more, we can chat in more details. Any further question?
Thank
Okay,
you.
thank
Thank
you.
you, Dr. Salman. Thank you.